for this first problem, I'd like you to evaluate and simplify the difference quotient for f of x is given here to find a simple expression for the slope of the secant line passing through f of x. So there's a lot of embedded information in there, a lot of words telling you what this is used for and all that, but really it boils down to get out your formula for your difference quotient. We wrote down to our notes yesterday, and then we are going to plug into that. So these are those notes that we took down yesterday. So check that you have that down correctly as you're now starting to use it. And since this is what you're going to be plugging into, notice that we're going to end up with some sort of an answer here. It's going to be in terms of A and H. All right, so we got our formula. We have our original f of x. Now what do we do with them? Well, basically we're now just plugging in the a's and h's where they're supposed to go into the f of x here in order to be able to make this formula. So let's see what that first step should be looking like. Make sure we're set up right there. All right, so the first thing I'm going to put in is f of a plus h. So that means I'm taking all of my x's in my original formula for this part and I'm replacing each of them with a plus h. So I'm going to end up with a plus h squared minus 4 a plus h plus 9. That's that f of a plus h part. And I'm going to be subtracting f of a, which means that in this part, I want to put a in for x. Remember to put this part in parentheses so we don't lose track of what's being subtracted. So then it's going to be a squared minus 4a plus 9, all over just h. So that's the first step, is that we're just plugging those values into the f of x in order to be able to then plug it into the difference quotient. Once you have this, now it's a matter of simplifying. All sorts of simplifying. So continue from there to simplify this as much as you possibly can. All right, so here you can see what happens when I go ahead and do the multiplication there, the distributing, all that kind of stuff. I've also gotten rid of all the parentheses. So this is the time when you especially want to check all of your signs. Make sure that all the positives are positive and all the negatives are negatives. Of course, otherwise it all falls apart. Yep, good catch. This should not be an h here. This should be a 4h. Remember the negative, but forgot the 4. So that would be 4h there. All right, and then from here, well, we're going to need some more room to work here. We now start combining our like terms, looking for anything that we can combine. And so let's go ahead and just start grabbing anything that is alike. So like I have an a squared here. I'm going to start looking for other a squareds. I have a minus a squared here. Well, that's rather convenient because those, of course, are going to cancel out, right? So I have no more a squared term left. Okay, next up, I have a 2ah here. Well, there are no other ah terms. So that's actually just going to stay a 2ah. So I'm going to go ahead and put that part down first. So we got 2ah. Next up, h squared. And there's no other h squareds either. So I'm going to go ahead and put in the plus h squared. Didn't have to change at all. All right. From there, the next one that I'll be checking out is the 4a, the minus 4a specifically. And here we do have a partner for that. We have the positive 4a. Well, what are they going to add to? 0. Awfully convenient. So those a terms just went to 0. All right, next up, I got my minus 4h here. It doesn't have any partners. No other like terms with that. So I'm going to have a minus 4h here. And then let's head over and let's see what is next. That'd be the 9. I haven't looked for the 9s yet. 9 minus 9, which, interestingly enough, once again, is going to give us 0. And so that's just totally gone. So the top simplified down quite a bit. You'll notice, though, that it is over h. Keep track of it being over h. One thing I'll see people do sometimes is they'll try to shortcut it by just kind of leaving off the h at each step until the very end, and then they say, well, I'll just add it in at the end. The problem is that sometimes they forget to add it in at the end, and it causes problems. You did all that work, and then skip that one little bit. It's not hard to write all over h. I suggest you write it in. You're not really saving yourself that much, but you are creating a potential pitfall. All right, the last thing we're going to do here is we're going to go ahead and simplify that down, which means canceling h out of every single term on both the top and the bottom. And so we end up with a final answer then of 2a plus h minus 4. And so that's what the whole difference quotient worked out to be here. And again, remembering what this is useful for. The a tells us like our starting x value. The h is the horizontal distance between that and our next x value. And based off of this short little formula, we now could figure out the slope of the secant line very, very easily. All right, so I'd now like you to find the slope of the secant line passing through f of x. This is the same f of x, you notice, at x equals 2 and x equals 5. Now, one of the questions you have to grapple with right off the top is what's a and what's h, right? At least I hope that's what you're worrying about, and not trying to like do this the long way after having done all the long way work already. Use what we just did. So I'm going to start by figuring out what a and h are. Now, I'm guessing most of you will have said that a was 2, just because that happens to be the first x value that was listed. That's fine. If a equals 2, though, what would h be? Well, you're starting at 2 and you're going over to 5.
3.
What is that horizontal distance? 3. And so in that case, h is going to equal 3. But what if you didn't do it that way? What if you happen to think of, well, I'm going to start with the a equaling 5. Could you do that? Well, you could actually, yes. What would h equal in that case?
-3.
You're going from 5 to 2. Notice since it's decreasing, yes, that's going to be a -3. So you actually can do it either way, but notice that if we're heading to the left, that h is negative. All right, so go ahead and use at least one of those to find your slope. Whichever way you did it, this is what your first line of work should be looking like. And in both cases, when you work all of it out, you end up getting 3. So notice, it doesn't matter which one you're choosing as a, as long as you then account for the h appropriately from there. So to finish up now, I'd like us to now write the equation of the secant line passing through f of x at the same x equals 2 and x equals 5 as the last problem was. All right, so let's take a look at this. Well, the nice part is we've already done a big chunk of the work in order to be able to do this. Because assuming that we're going to give it in slope-intercept form, for instance, we know that we're going to end up with the final equation of y equals 3x plus b. Now, we don't know what b is yet. We're going to need to figure out what b is. But I do know that the 3 here is a 3 because of the work we just did on the last one. Remember, I used difference quotient to find the slope of the secant line, because that's what difference quotient does. And so I already know this much. Now it's just a matter of figuring out what b is. And there's a few different methods you can use to solve it, but for all of those methods, I'm going to need to know at least one y value. Now it doesn't actually matter which one though, but I am going to actually have to calculate that y value. So let's say I want the y value that goes with x equals 2. I'm going to have to plug 2 into my equation here to figure out what the y value is that goes with it. You could also use the 5 as well. That would also work here. Let's go ahead and do that then. And so when we plugged in 2, we got 5. That means that the y coordinate is 5, or in other words, I have a point at 2, 5. You could have done the same thing by plugging the 5 in. That would also work. If you had done that, you would have gotten the point 514, just in case you went that direction so you can check yourself. But I'm not going to be using that as my example, and I don't want you wondering, wait, how did I use it? Because I'm not going to use it, so I'm just going to take that off there. Now, there are a couple different methods you can use to find our equation, to find our b value. One is that you could take our coordinates and plug it right into this. So, like we can do 5 equals 3 times 2 plus b. And now we can solve for b. Okay, so that would be 5 equals 6 plus b. I would subtract the 6 from both sides, so I'd have negative 1 equals b. Well, if I then plug that in, I get a final equation here of y equals 3x minus 1. That is our final answer, at least in slope-intercept form. Notice I'm saying at least in that. You could have also given your answer in different forms as well. There was nothing magical about having to use slope-intercept here. You could use point-slope. I know a lot of people don't go to point-slope right away, but it actually is a very good method for this sort of thing. If you had gone that route, you would have done y minus 5, that's the y-coordinate, equals 3 times x minus my x-coordinate of 2. That's also a valid equation right there. That would also work. But if you really, really wanted to start with that but still get a final answer in slope-intercept, you could distribute into 3 and then add 5 to both sides. You still get to the same place.